This is linear algebra 4.2. We studied the null space previous video. Now we're going to talk about column space of metric A, guys. So make sure you understand definition of each section. So let's start with the definition of a column space. So what is column space of metric A, guys? Metric gonna be m times n. So this is the size, so we can write the metric as column vector. That's a1 to the an. So that's the metric of A. That it is a column of A. Then we're gonna find the linear combination of the column vector. That's we call span. What is a linear combination? That's going to be x1, a1, x2, a2. This is vector, guys. xn, an. So x1, xn is going to be all your number. That's we define the span, right? So column of A gonna be, guys, you're gonna write down metric form. You're going to find the B vector. So you're going to say this is B. You're going to put this is B. So that's I'm going to put it. This one is rewrite it. B going to be, how can I make a B? A times X vector. X vector is what? X1, X1. X vector going to be X1 to the Xn. So this one is Rn. So X vector going to be Rn. So that's another way you write the column space of A. So linear combination of column of A, or you say matrix A times X vector. That's you correct them. That's gonna be column space too, guys. Okay. Also, you're gonna see this one is we are not gonna prove it. Column A is, of course, this is the subspace of Rn, guys. Okay, that's also you're gonna see that's the subspace gonna be Rn. Okay, let's practice with some example, guys. So this example gonna be we're gonna find the metric of A such that column space of A. So we're gonna figure it out what is gonna be A, what is gonna be column vector of A, which generate column space, okay? You're gonna start with this one, guys. Start with this one. So before we start it, guys, definition of this one, span, linear combination of column 1, column 2, I don't know. We're gonna figure it out, okay? We're gonna figure it out. So this one is linear combination of column vector. So how can we figure it out, guys? This one is, I talk about previous slides, guys. A, here is A. What is coefficient? Here is a 6, here is a 1. Third one is a -7, here is A. That's you write it. Okay? Plus, second vector, column vector gonna be, let's look at the B. Here is a B, here is B, here is nothing. So B gonna be coefficient -1. Here is a coefficient is 1. Third row gonna be no B, that's 0. Here is the B. So this column is linear combination of what? This one is linear combination. A U vector, I'm gonna say this is U vector, plus B V vector. Everything make sense? So this one is I'm gonna say column space of A, span of two vector, U vector and V vector. Because that's the linear combination of U vector, V vector. Okay, so what are you gonna say? So we're gonna find the metric A. Metric A is column, just U vector, V vector should be column of metric A. So column here, column here. Column vector. So first column, U vector gonna be 6, 1, 7. Second column, -1, 1, and 0. So that's you're gonna find the metric A. Guys, make sense? Okay, that's you did. Okay, go to the next one. Okay, this is a practice problem. We're gonna combine two concepts into these practice questions. They give the metric A, they give the vector, right? The metric A gonna be 3 by 3 metric. This is vector is R3. So we're gonna first check U vector is null space of A. That's we're gonna check it. Which meaning is what? This meaning is you have to check A vector U gonna be 0. That's you have to check it, right? Second is gonna be U vector gonna be linear combination of column of metric A. That you have to check it, guys, okay? So which meaning is this one gonna be U gonna be A vector times X. X gonna be R3. Can you find it? That you have to check it, guys. So it's very related to the previous chapter we studied. First one is gonna be you plug in the U here. That's make 0. That you're gonna check it. Second is the column of A gonna be, you're gonna find the X vector in the R3. So you're gonna do this one, guys. You're gonna do by yourself and check your answer with me later. Welcome back, everyone. Let's check this one. Let's check this one is AU gonna be 0 or not. Let's go here. Metric multiplication. Vector U gonna be 3, 1, 0. I'm assuming everyone already did it. 2 times 6 is 6. Negative 6 times 1 is negative 6. Negative 12 times 0 is 0. Second row, negative 9 plus 9 plus 0. Third row, 0, 0, 0. 0 plus 0 plus 0, right? So you have 0, 0, 0. Oh, A of U gonna be 0 vector. So you're gonna say you're gonna be null space of A. You're gonna say that, okay? Solution of homogeneous equation, right? Second is, can you find X in the R3? This one is a metric equation, guys. How can find it? Which meaning is you're gonna change this argument to the metric. This system gonna be consistent. Then we're gonna say this have a solution, right? So we're gonna change this argument to the metric first, guys. So 2, negative 6, negative 12, negative 3, 9, 9, 0, 0, 1. Here is U vectors 3, 1, 0. That's augmented metric. We have find the solution. So that case, you're gonna say X gonna be R3, right? That's you're gonna find it, right? Let's do the operation. Everyone, you try it. Where is it first, guys? Here is gonna be, this is a pivot. Pivot make 1. So I'm gonna do the two operation at the same time. This one gonna make 1.5, R1, go to the R1. This one I'm gonna make the 1, 2, guys. Negative 1/3, R2 going to R2. Guys, keep in mind, there is only one way to do it, guys. You might different way, but it's fine. But you're gonna focus on pivot right here. So 1, negative 3. Here is negative 6. Here is 3/2. Second row, 1, negative 3, negative 3, negative 1/3. Third row gonna be 0, 0, 1, 0. Let's see you did it. What is gonna be next, guys? What is next target? This should be 0, guys. This should be 0. So you have idea, right? What are you gonna do? So negative 1, R1 plus R2 going to R2. So you have new one. 1, negative 3, negative 6. 3/2. Second row is 0, 0, 9, 11/6. 0, 0, 1, 0. You have it. Okay, so what are you gonna say when you say this is consistent and inconsistent? Everyone remember the definition of consistent and inconsistent? This is not inconsistent. Why? This is inconsistent system. What? Go to the third row. Third row gonna say x3 is 0, right? But second row say what, guys? The second row say, look at this one. 9x3 equal 11 over 6. So this one say different story. X3 is 0 is right there. It can be this is true, this is false. So it doesn't make sense. So this is my equation is inconsistent. So which meaning is, guys, you can conclude there is no x vector R3 such that ax equal b u, which meaning is u is not column space of A. That's you can have conclusion, guys, okay? Okay, that's we talking about null space, column space, okay? So now another practice problem, you guys are thinking about how can find the non-zero vector in the column space. How are you gonna find non-zero vector in null space? As usual, you pause the video, you can try to solve by your own. Welcome back, everyone. So here is find the non-zero vector in column A. So let's go back, quick go back to definition of this one, guys. What is definition of column A? Column space of A gonna be span of A1 vector, A2 vector, A3 vector, A4 vector, right? What is A1? This is A1. This is A2 vector. This is A3 vector. This is A4 vector. So now we say you have find the linear combination x1, A1, x2, A2, x3, A3, x4, A4, x1, x4 is all your number. So all your number meaning is, guys, you can pick any number. So I'm gonna pick, guys, you're gonna pick x1 is 1, x2 is 0, x3 is 0, x4 is 0. Still in the column space of A. So which meaning is gonna be, I'm gonna put the B vector, okay? So x1 is 1, A1 vector plus 0, A2 vector plus 0, A3 vector plus 0, A4 vector. Oh, so A1 vector in the column space of A. So what is A1? 1, 0, 0. Does it make sense? Same thing is A2 vector in column space of A. Okay, that's how to understand the column space. Second is non-zero vector in the null space. What is the definition of null space? You're going to find the x vector such that ax gonna be 0. That's you find that solution right there, guys. So we have find the solution of non-homogeneous equation. That's you have to do it, right? So this one is gonna be augmented metric. Let's make augmented metric, guys. So augmented metric, I'm gonna little do fast, guys. 1, 0, 3, 4. Here is constant term is 0. 0, 1, 4, negative 1, 0, 0, 2, 0, 6, 0. So this augmented matrix is supposed to have solution. Then that's going to be x, right? So everyone can see that what kind of row operation you need. Oh, that's very nice. Okay, here is a pivot already, right? Here is a pivot right there. So you have make this is a 0, so which meaning is negative 2 R2 plus R3 gonna be R3. Got it? 1, 0, 3, 4, 0, 0, 1, 4, negative 1, 0, 0, 0, 8, negative 8 gonna be 0, guys. All right, so this one, you're gonna see another pivot right there, guys, right there. This should be 1, so divide by 8. Another way you're gonna say this one gonna be, you wanna do 1 over 8. R3 gonna be R3. So you say this one, 1, 0, 3, 4, 0, 1, 4, negative 1, 0, 0, 1, negative 1, 0. Can you see that, guys? So let's mark the pivot. Here is a pivot, here is a pivot, here is a pivot. So here is above is 0, here is a 4, here is a 3. That's all make 0. That's your job, right? So let's do another operation. So you have to do two things right there. Negative 3 R3 plus R1 gonna be R1. That's first one. Negative 4 R3 plus R2 gonna be R2. I do the two row operation to make this one is 0, guys. So 1, 0, 0, 7, 0, 0, 1, 0, 3, 0, 0, 0, 1, negative 1, 0. Okay, so you have it right there. Okay, pretty good job right there. So you have find all the people right there. 1, 1, 1, right? So this one changed the system of equation, you guys. Can you do that right? So this one is, which more free variable? Can you see that this one is x1, here is x2, here is x3, right? So there is no x4. So x4 is free. So first one is x1 plus 7x4 is 0. Second row, x2 plus 3x4 is 0. Third one is x3 minus x4 equals 0. x4 is free. So that's you find it. Let's find the metric. Let's find the metric. X gonna be first one right there. X1 is negative 7x4. X2 gonna be negative 3x4. X3 gonna be x4. X4 is free. So you have negative 7x4, negative 3x4, x4, x4, right? x4, x4. So you're going to take out x4. So negative 7, negative 3, 1, and 1. x4 is any real number. So can you find any non-zero vector in the null space? So you can pick anyone. A4 is going to be 1, 2, whatever. So I'm going to pick x4 is 1. So this one is 7, negative 3, 1, 1. Should be null space of A. Guys, make sense? Basically, what you did with all the null space column space, you have understand the definition of each space.